Cool, we're live. Welcome everyone. This is this week's webcast. I'm Anthony.
I'm Kelly.
Today we're going to be going over a really cool tool called Python Tutor. This is a website developed by a computer science professor to help people learn how to code. And I think it's a really cool way of visualizing the flow of a program and seeing what steps are getting run in your program at what time, where different things are in memory. Really cool thing to help out with managing variables, understanding global versus local scope. So let's dive right in. Just going to share my screen here. And all right. So I have a file here on my desktop. It should look familiar to those of you who have gotten up to the end of Stage 2 Work Session 5, because this is the Mad Libs generator. Actually going to hide my dock here to get us lots of screen real estate here. Make that a little bigger for y'all to see. So this is the same thing that you have been working on in Work Session 5. We have a play game function that's sort of like the main function of the program. And we have a word in position function that, or word in parts of speech, I guess is what POS stands for, that tells us if a word in our string is one of these like parts of speech, like noun or verb. We have some test strings and test parts of speech up here. These are a little different than what are in the file that you download at the end of Work Session 5. I had to shorten them in order to make Python Tutor look nice, and you'll see that in a second here. And at the bottom, we actually call and print the result of play game. So let me switch back to Chrome here, and what we have here, I'll actually go to the Python Tutor homepage first. This is Python Tutor. It's not necessarily the most beautiful website in the world, but it does its job very well. So Python Tutor, we can see, is created by this guy, Philip Guo. And he's really just trying to help people learn how to program. And it's a really cool tool. It has lots of different language capabilities. You can do Python, Java, JavaScript, whole bunch of different stuff. And basically what it's going to allow you to do is it allows you to go, as you can see in like this example here, it goes step by step through some code and lets you visualize what's going on. So we're going to do that with the Mad Libs generator. So we'll click Start Writing and Visualizing Code Now. And we'll get a little text editor.
And so, Anthony, right now you have selected Python 2.7.
I have.
Awesome. So you can select a whole bunch of different languages and test it out right there.
Exactly.
Neat.
Yeah. You could do Python 3 if you're coding for that. You could do Java, C. So this is something you could use for any language. Well, not any, but a lot of different languages that you're learning.
Awesome.
So I'll switch over to Sublime and copy and paste the Mad Libs generator in. Let's see, we even got some syntax highlighting. Nice job there. And let's visualize execution. You can even, this is kind of a funny feature. This was actually made for tutoring. So one thing they have is like you can say how confident you're feeling about your code. So maybe I'm like feeling very excited, or maybe I'm like really frustrated. Don't really have to do that, but I think it's cute. Anyway, we'll start visualizing execution. So now we're taken to this window, and I'll try to explain what's going on here. Basically, on the left, we have the code that we pasted in to the text editor. And on the right, we're going to see different information about our code as it runs through step by step. And at the bottom, we'll see different steps that it's walking through. We can edit the code, and we'll move just like step by step as we go through. So, and we'll see these different arrows will appear on the left next to the line numbers. And that's going to kind of help us keep track of where in the code we are. We'll see that a green line will represent a line that was just executed, and a red line represents a line that is the next in line to be executed. As you can see, we haven't done anything yet. We're on the 0th step. There's a red line that lets us know that the first piece of code is line 2, since line 1 is a comment. Nothing has been executed, so there's no green line. So we'll just step forward. And we see this kind of graphic over here on the right. And what's going on here is it's telling us that we've defined this variable named parts of speech 1, and we've defined it in the global frame. So remember that variables have this concept of global versus local scope. Global variables are those that are accessible throughout your entire file. They're accessible by all functions. They're really best used for constants, things that don't change. And so we see here we have defined as parts of speech 1, and it has this arrow that's pointing over to a list. And we see the list segmented. We have plural noun, noun, name, and verb in this list, and we even can see their indices up on the top here. And if we move forward, you might already can kind of guess what's going to happen here. We're just going to find another variable in our global scope. This time it's a string. Note pointing outwards to something. It's just putting it in as a string here. There's a good reason for that. You'll see why a little bit later in this code. Now, what's going to happen next is actually something that might trip up some students who are just starting out on stage 2. We have line 8. We are defining a function. Now, you may think that we define the function, and what do you think is going to be after we execute this line? What will be the next line we execute? What do you think, Kelly?
Well, I know what's going to happen, but what I might think, given the last 2 things, is that word in parts of speech will go through all of the steps within that function, because so far we've just kind of been going down the line in the code.
Right, exactly. It's very easy to think that we execute line 8 and then naturally we just go to line 9, go to the next one. But as we see when we move forward, it's not what happens. We actually go to line 8. We put word in parts of speech in our global frame, and we see that it points to a function. But the next line to execute is not line 9, it's line 16. And some students get a little tripped up on this kind of idea, but when Python defines functions, it doesn't run them immediately. So we've defined the function word in parts of speech. We're saying we know that this is a function that exists, and we have a definition for it. But we're not going to do anything with it yet. So lines 9 through 12, the actual function code is not executed until we call it. So similarly, if we go down here, our next line to execute is line 16. What's going to happen is we'll put play game in our global frame and then skip down to line 30. And we see that's exactly what happened. We define play game. Play game is in our global frame, and it points to this function here. So that's all good. And now at line 30 is when we're actually calling the function. We're calling it with the print statement. So we'll move forward. We'll execute line 30. And we'll see line 30 calls the play game function. Now notice that there's a kind of a color change here, right? So before, global frame was blue. Global frame is the currently active scope. We're currently executing code in the global scope. Once we call play game, we're now in a local scope. We're in the local scope of this play game call. And play game took in a couple of parameters. It took in a parameter called mlstring and another parameter called parts of speech. And Python Tutor actually does something really interesting with those parameters. Notice that if we look over here and we look at our play game scope, we have 2 variables. We have the 2 parameters we passed in. We have mlstring, which is equal to hello name, I'm a noun. And that's because at line 30, we passed in the testString1 variable as a parameter. And for parts of speech, we actually have this arrow that points up to the same list that parts of speech 1 points to. And this is what I was talking about, is that good reason why we have these arrows for the list, but not for the string. And that's because you all might remember from stage 2 as well, this is due to the immutability of lists. And basically, I'm going to just pop over to my terminal to demonstrate this a little bit. Make
So
that a little bigger.
immutability, that sounds like a big concept.
It is a little bit. Basically, in simple words, what that means is even though these two variables are different, right? We have parts of speech, the local variable that's local to play game, and we have parts of speech 1, the global variable in our global frame. Even though they're different, because we have essentially set them equal to each other, they're pointing to the same value. And that is a attribute or feature or something of lists. This is something that is true about lists as values. It's not true about strings, and it's not true about integers, or it's not true about many other values, but it is true about lists. And we can see what's going on here. If I start Python here in my terminal, and I define like list1 equals Kelly, Anthony, and Rahul, your IPND coaches, if you didn't catch that. And then I say list2 equals list1. Well, I can print out list1 and see, that's what's expected, and print out list2, and that's what's expected. Now, if I say I change the last element of list2, let's say, list2, 2. So that refers to Rahul, the second indexed element, so 0, 1, 2 of this list. Let's say I change that to Mark, and then I print list2. Well, yeah, that's expected. I got Kelly, Anthony, and Mark now. We've replaced Rahul with Mark. But interestingly, if I print list1 also changed, which is kind of interesting because we didn't do anything to list1. We only did it to list2. And that's because of what Python Tutor is visualizing over here. List1 and list2 are pointing to the same list. So similarly here, parts of speech 1 and parts of speech excuse me, are pointing to the same list. So if I were to change plural noun to adjective or something, it changes it for both of them. And that's just something to watch out for when you're dealing with lists. Copying lists is actually a very complicated concept. As for why lists do that, that's beyond the scope of IPND, but if you're interested, it's actually a very interesting topic. But anyway, we'll keep moving on here. So we'll move forward. What we'll see now is we've started the play game function. We've started this call. Now we'll actually be running through the code that we have here. So if I step forward, I'll define a new variable. And notice again, within the local scope of play game, replaced points to an empty list. Stepping forward again, we have this for loop for word in ML string. Actually, we just execute ML string equals ML string dot split. So we've now replaced the string that was an ML string with a list. So now instead of the list hello name, I'm a noun, we have the string hello name, I have a list hello name, I'm a noun.
So now the ML list is pointing to the list because now it's an immutable object.
Exactly.
Okay.
Exactly. So if I were to make a copy, it would change both, just like we do with the parts of speech list here.
Cool.
So moving forward again, we start a for loop. With that for loop, we actually define a new variable named word. Since that's what for loops do, we're saying for word in ML string. So we set word, the variable word, equal to the first list item in this list, which in this case is hello. And what we're going to do is basically the way this code works is we're going to run through this list and decide which of these are parts of speech and react appropriately to them for our Mad Libs. So stepping forward, jumped ahead a little bit. How do I get rid of that?
You just step forward now.
Well, I'll just refresh.
Perfect.
And repaste it in. I must have pressed something that I did not want to press. So, oops, went a little too far. There we go. So we've started our for loop, and our next line is this one. Replacement equals word in parts of speech called on word in parts of speech. And what this function does, remember, is it will take word, hello, and determine if it is in this parts of speech list, which, as you can probably guess and see, it is not. And since it is not, it will return none. And let's see that actually happen. If we move forward, we have a new local scope, word in POS. Notice that the color changed again. Play game is no longer blue. Global frame is not blue. Word in POS is blue. That is the currently active scope.
All right, so we're only working with variables that we have access to in that function right now.
Exactly.
Cool.
If we wanted to get the value of replaced, for example, we cannot do that. We are in a different scope right now. We can only access these two variables along with the global frame, which we can always get to. And so when we call word in POS, we have two parameters. We have word, which at this moment is hello. And we have parts of speech, which is the same list that we've been pointing to for this entire thing. And now we'll move forward. And we have another for loop. So we define another function, this time POS, for POS and parts of speech. In this case, it's set to the first item in the list, plural noun. And we're checking if POS in word. So is plural noun in hello? No, it's not. So we'll move back up to the for loop, and this time we're looking at noun. And the next line will be is noun in word? Nope. So we'll continue, name, continue on, verb, nope. And we'll keep going. And return value, none.
Nice.
So we went through the entire list. We didn't find anything. We're going to return none. So now if we move forward one more time, we see replacement gets added to the play game local scope. The word in POS scope disappears because that function is done executing. And replacement gets the return value from word in POS, which in this case is none. So the next line says if replacement not equal to none, well, replacement is equal to none. So we're actually going to jump down to this else and replace.append word. So we're going to append word, hello, to replaced, which is an empty list. And when we move forward, we'll see hello appear in replaced. And now we're still in this for loop. So we're going to move back up and now do the same thing with the next word and then the next word. So there's a little bit of repetition going on here. We'll just keep moving forward here for a while. Actually go back. So see, now we have name with a period. We'll call a new scope of word in POS, this time with word equal to name, parts of speech, pointing to our parts of speech list. Moving forward for POS and parts of speech, move forward again. This time POS is plural noun. Is plural noun in name? No, it's not. Move forward, redo. Now we've got noun, no, name. Ooh, this is interesting. So now we have this if statement is true now because POS is name and word is name with a period. Now if we move forward, we're going to return name instead of none. We're at this turn here, not this one. And I just did it again with this thing. That is what I cannot do.
Which one did you click?
I can't highlight.
Oh, sure.
Oh.
It undoes it.
Okay, I'll take that.
Perfect.
I don't know. That's interesting.
It's a new feature that we just found.
I guess so. So we're returning name now instead of none. And when we move forward this time, we're at if replacement not equal to none. Well, we can see here replacement is name, which is not none. We'll move forward and we hit a raw input. And you see this little box come up. So type in a name, we'll say Kelly, and submit. And now we have a new variable, user input, whose value is Kelly.
Neat.
And the next line will replace, we're doing word equals word dot replace replacement user input. So now word, see, word is now Kelly with a period. We've replaced capital name with Kelly. Move forward again, and we append Kelly to our replaced list.
I see.
And now we have hello Kelly.
So one thing I noticed, Anthony, before it got to the user input, it said that there were 36 steps.
Right.
And as soon as it got to user input, it got the user input and then showed that there were more steps.
Yep. So basically, the reason why it's doing that is because this is part of, I guess it's mostly a quirk of Python Tutor more than anything. It's executing as much code as it can get on its own. As soon as it hits that raw input line, the program is essentially in like almost like a halting state, and it's waiting for the user to respond. So Python Tutor, as far as it can tell, knows that there are 36 steps to reach that first raw input moment. After it reaches that, there are going to be several more steps. And that's because it doesn't know what the value of raw input is going to be until a user responds to it.
I see. So based on whatever the user input ends up being, it can give you the number of steps that are left.
Exactly.
Great.
Exactly. And actually there will be, if we go through this whole thing, there will be more than 81 steps because as we can see in our ML string list here, we also have noun at the end, which will get replaced because it is in parts of speech. So there will be steps after we do a second raw input here.
Great.
So yeah, the rest of it is pretty much everything we've seen so far. We've put Kelly in the list. We're going to start a new for loop, this time with the word I'm. And we'll just keep going through. We have a new word in POS scope. We're just going to iterate through the list, plural noun, no, name, no, verb, nope, return none. And then when we return none, we'll go to the else, and we'll append I'm to the replaced list. And we'll just kind of keep going through that. A is not one of the parts of speech, so it's just going to keep doing that. Return none, come back to the function, none replacement is equal to none, so we'll execute the else and append A to the replaced list. And then the last step, noun. So now we're in word in POS again. Noun, but noun is noun, so we will return noun instead of none. Come back here. Replacement is now equal to none, so that is, or sorry, replacement is not equal to none because it is equal to noun.
Correct.
Those words sound very similar. We want a noun now. Let's say computer. Submit.
Great.
And we'll move forward. Same thing here. We've replaced, at this step, we replace noun with computer. And we append computer to the replaced list. And now here's the last bit of kind of interesting code is we're at the end of the for loop. So we just execute the for loop. There's nothing else in ML string for us to execute. We hit the last list item here. So the for loop is done. We come down to the bottom. We have replaced equals space dot join replaced. That's going to join this list here with a space in between each item. So it looks like a sentence. We move forward and we see replaced has been changed from this list to a string. Hello, Kelly, I'm a computer. And we move forward, we return, hello, Kelly, I'm a computer. Move forward one more time, and that play game function has been executed. And we come down here and we see our printed output because we called print on the return.
That's pretty great.
Yeah.
It's super useful for visualizing. I'm a very visual learner, and seeing the red arrow hopping around through the program is really useful for me to like keep track of where I am in each of the functions. I think
Totally.
this is really neat.
Yeah, this is a great thing when you're starting out, especially. It's what was that?
Oh, so what I was wondering about this, when you're loading in code
Sure.
on that front page where you're copying and pasting whatever program you want to run, I saw a few different settings at the bottom, and I was wondering what your preference is on the settings for displaying the visual results. I think the default ones hide the frames.
Oh, I see.
Yeah,
so
there's
these are
some-
going, that's interesting.
Mhm.
I did not realize that. That's pretty cool. So if we were to like, edit this code and say we wanted to show exited frames,
You can render all the objects in the heap.
use text labels for pointers.
Yeah.
Interesting. I like the arrows though.
Yeah,
So
the arrows are great.
I believe what this will do is so we've defined play game. We're in words and POS now. When we exit word and POS, I believe what will happen is, we keep this. Notice it's like kind of grayed out here. So
okay.
This is kind of keeping a record of the fact that there was this scope at one point of time for you to kind of visualize that even.
Cool.
And I'm wondering what will happen when we call word and POS a second time, and now this is the new scope.
Nice. So with that, you can kind of see the progression and how many times a function gets used.
Yeah, exactly.
Cool.
You can even see how the return values have changed based on the inputs. Like if we were to go through this, we can see, so when we passed in hello as word, we return none. But when we passed in name, we return name.
Neat.
Which makes sense. That's the functionality we want. So that's pretty cool. I didn't know that. That's a neat thing.
Yay features.
Yeah, yay features. We're discovering all sorts of new features in here. So yeah, definitely check this out, especially if you're having some trouble or want some more help with understanding how code executes, especially with seeing that code executes line by line, but doesn't necessarily run code line by line. As we saw with like our function definitions, we didn't go from line 8 to line 9, but from line 8 to line 16. Yeah, I think this is a super great tool for you all to use, especially for the stage 2 project. Might want to put your own code in there and see, is Python Tutor visualizing it the way that you expect it to?
Right. And one thing that I remember you telling me about with Python Tutor, if the program has too many steps, what will happen? What is the maximum number of steps that it will run?
Right. So in preparing for this webcast, I actually was going to use the day between dates problem from lesson 2.7. And when I put it in, Python Tutor complained at me because day between dates took more than 1,000 steps to execute. The reason for that being that the way the day between dates works is you take the 2 dates and you manually count each individual day between those 2 dates. So even on days that were only like a month apart, you're still doing iterations of like 30 days, right? You're doing however many steps it takes to count one day 30 times, and that adds up really quickly.
Plus any of the other functional lines throughout.
Exactly. So any functions you define or any variables you define, those are all steps too. So it's not great for huge pieces of code. That's why this is a learning tool. It's not like a developer's tool. But it's great for simple things like the Mad Libs generator.
Awesome. I was also thinking it could help people be motivated to write really efficient functions that don't take too many steps.
It could.
Perhaps.
That's true. Yeah, I've been thinking I want to do a competition. Who can write the shortest stage 2 project?
Oh man, that sounds like a great. I think that'd be fun. Do the challenge. Cool. So it doesn't look like we have any questions in the Q&A at the moment. We'll stick around for another minute or so.
Sure.
But yeah, thanks for joining us if you joined us. And if not, enjoy watching the playback. And I hope it's useful for you.
Yeah, me too. Cool. And yeah.